Mathematics, Analysis and Approaches, Paper 2, Time Zone 1, HL, November 2025. This is a question from Section B, a 10th question which carries 17 marks. He's talking about an aeroplane which is landing 100 meters in front of a stationary car. So this car is stationary, and then this aeroplane is landing 100 meters away from it, in front of it. Now, the moment the aeroplane is landing, the car begins to travel in the same direction, which moves along with the plane in this direction. T represents the number of seconds after the aeroplane lands. So the moment it lands, the time is 0, and then the time starts counting. And T is in seconds. Make a note of that, please. For T greater than 0, the velocity of the aeroplane and the car in meters per second can be modeled by the two equations given here. This is for the aeroplane and this is for the car. So the first part of the question says when the aeroplane lands right on the speed of the aeroplane and then the speed of the car. We know that when the aeroplane is landing, time is going to be 0 seconds. And I can simply substitute the value for T as equal to 0 here. So if I do that, the velocity of the aeroplane is simply going to be 60 meters per second. And obviously the velocity of the car, as he has told it, 0 meters per second. It also makes sense because the moment I substitute the value for T as equal to 0, this is going to become a 0 and therefore 0 meters per second. The value of T when the aeroplane and the car have the same speed. So what does it mean when the vehicles have the same speed? It simply means that the velocity equations are going to be equated, which means I will be able to say 60 e to the power of minus 0.1 t should be equal to 5t. We will use the calculator to solve this. So that's when the velocities are going to be the same, which is at 6.35 seconds. So here I will have t as equal to 6.35 seconds or 36. Okay, the speed of this time, all I now need to do is to take the value for t and substitute in one of the equations. I've already plotted the two curves, which means if I substitute t as equal to 6.35 in any one of the equation, I should get the velocity. So on the graph, I can see that the y coordinate is 31.78. That is going to be your answer. So speed is simply 31.8. So I can say that the speed is 31.8 meters per second. Let dt represent the distance in meters between the car and the back of the airplane. So the distance between the car and the back of the airplane is 100 meters initially. However, as and when the airplane starts moving forward, the car also starts moving in this direction. So the distance between them could be reducing or could be increasing, but it's not going to be 100 meters because they both are traveling at different speeds, you see. And now what I need to know is the distance equation. So how do I get the distance equation? Well, if I integrate velocity, I get the distance. And if I differentiate the distance equation, I get the velocity. Again, remember, when I differentiate the velocity equation, I get the acceleration. So distance leads to velocity and leads to acceleration, and the other way around. Integrate and then integrate. So you should get that. So let's go ahead and integrate both the curves. So I can write the distance equation as integral So he is also given us an initial condition, which is that the distance between them at time 0 is 100. I'm going to make use of that to find the value for C. All right. So that's the constant. Hence, find how long it takes for the car to reach the back of the airplane. So this is the distance between the car and the aeroplane. So if the distance is, 0, that's when it would have reached the back of the car. So what I can do is I can say the distance itself is 0, and then I try to solve this. So when I see, I notice that the curve is cutting the x-axis at 2 different points. I'm going to quickly calculate the zeros here. That's your first 0. And your second 0 is going to be from there to there, which is 15.06. Right? Obviously, the time cannot be negative, so I'm going to choose 15.06 as the value. So it takes 15.06 seconds to for the car to reach the back of the plane. Find the distance traveled by the car when it reaches the back of the plane. All I now need to do is to take the value, the time as 15.06, and enter it into the distance equation of the car. So the distance equation of the car can be found out by integrating this, which is basically 5t squared by 2. I can integrate and then substitute the value. What we can also do is to go on the calculator. So that's going to be your final value, meters. And though it is looking like a lengthy, extensive, question, very easy if you know how to use the calculator. It can be done much more faster. I did not use any major calculations. Most of it was done using the calculator itself, including the integration. That's it for this video. Thank you.